our planet may look calm, but beneath its crust lies a restless world of heat and movement. The Earth's interior is made up of layers. The solid crust, the hot mantle, and the blazing core at the center. Deep in the mantle, intense heat melts rocks into a thick, glowing liquid called magma. The Earth's crust is divided into enormous puzzle pieces called tectonic plates, which are constantly moving. Where these plates collide, pull apart, or slide past each other, cracks form, and through these cracks, magma begins its long journey upward. This is the birthplace of a volcano, a process that can take thousands or even millions of years. Once magma finds a weak spot, it starts to rise through layers of rock. As it rises, it gathers in a large underground pool called a magma chamber. Inside this chamber, molten rock mixes with dissolved gases, mostly water vapor, carbon dioxide, and sulfur dioxide. These gases expand as pressure increases, just like bubbles in a shaken soda bottle. The magma chamber acts like a balloon. The more magma and gas it holds, the more pressure it builds. The ground above begins to bulge slightly, though often too slowly for us to notice. But deep below, the volcano is loading energy for its next eruption. As pressure continues to build, the volcano begins to send warning signs. Tiny earthquakes called tremors shake the ground as magma moves upward through cracks called vents. Steam and gases escape from the surface, forming fumaroles, vents that hiss and smoke. Scientists called volcanologists monitor these changes, using instruments that detect ground movement, temperature, and gas levels. Even small patterns, such as a rise in sulfur gas or swelling of the ground, can signal that magma is nearing the surface. It is as if the volcano is whispering, "I am awake." Then, suddenly the pressure becomes too much. The earth splits open and magma bursts through the surface in a spectacular explosion. Lava fountains soar hundreds of meters into the air, glowing like liquid fire. Ash and gas rise high into the sky, forming a towering eruption column that can reach the stratosphere. Inside the dark ash cloud, static electricity creates volcanic lightning crackling across the sky. Streams of lava flow down the mountainside, setting forests ablaze and reshaping the landscape. Some eruptions last only minutes. Others can continue for days, weeks, or even months. The volcano has released its fury, and the world above is forever changed. When the eruption ends, silence returns. The mountain stands shrouded in ash. Rivers of lava cool and harden into black rock. But this is not the end. Volcanic ash is full of minerals like potassium and iron, which make soil rich and fertile, creating perfect ground for new plants to grow. Within months, small green shoots appear, and within years, the land flourishes again. Life returns, born from fire and stone. Today, scientists use technology to understand and predict eruptions better than ever. Satellites orbit Earth, measuring heat and shape changes in volcanoes. Drones fly close to craters to collect gas samples and thermal images. Instruments called seismometers detect underground tremors that hint at magma movement. By combining data from all these sources, scientists create early warning systems that save lives. Volcanology, the study of volcanoes, also helps us understand the history of our planet. Without volcanoes, Earth as we know it would not exist. Volcanoes are both destroyers and creators. They tear apart landscapes yet build new ones. From the depths of the earth, magma rises, erupts, cools, and becomes new land. This is the planet way of renewing itself, a continuous cycle that has shaped Earth for billions of years. Every eruption tells the same story. From fire comes life. And somewhere deep beneath your feet, the next volcano is already forming.